We're going to evaluate the integral of the square root of x squared plus 25 divided by x to the fourth using trigonometric substitution. Now, the type of integral we have contains the square root of x squared plus a squared. So we match a squared to 25 and take a to be 5. The type of substitution for such a radical is to let x be a times tangent of theta. So in our case, we're going to let x be 5 times tangent of theta. Therefore, dx is equal to 5 times secant squared theta d theta. And replicating what's in the radical, we have x squared equal to 25 times tangent squared theta. X squared plus 25 is 25 times the tangent squared theta plus 25, which is equal to 25 times tangent squared theta plus 1, and that's 25 times secant squared of theta. And so let's go ahead and return to the integral that we had. The integral was the square root of x squared plus 25 over x to the fourth. We made the substitution x equal to 5 tangent theta, and the resulting integral now in variable theta looks like this. We have under the radical 25 secant squared of theta. In the denominator we have x to the fourth, which is 5 to the fourth power, that's 625, times tangent to the fourth, and dx is 5 times secant squared theta d theta. We're going to assume that square root of secant squared is secant. Square root of 25 is 5 times secant theta divided by 625 tangent to the fourth theta times 5 secant squared theta d theta. So canceling and simplifying, 5 times 5 is 25, 625 divided by 25 is 25. So we have 1/25 out here. In the numerator we have secant cubed of theta. In the denominator we have tangent to the fourth of theta. So this is what we have left to integrate. This is best integrated by rewriting both secant and tangent in terms of sine and cosine. So secant cubed is 1 divided by cosine cubed of theta. Tangent to the fourth is sine to the fourth of theta over cosine to the fourth of theta. And simplifying this, we have 1 over 25 times the integral of cosine to the fourth theta in the numerator. In the denominator we have cosine cubed theta sine to the fourth theta d theta. So this is cosine to the fourth over cosine cubed. We end up with the following. We have cosine of theta in the numerator and sine to the fourth of theta in the denominator. So now we can make the substitution. Let u be sine of theta. Du will be cosine of theta d theta. And so with that substitution, we get 1 over 25. The numerator is du, and the denominator is u to the fourth. So the 1 over 25, integral of u to the minus 4 du. So this is 1 over 25 u to the negative 3 over minus 3. We can add a constant of integration c, but we have to express the answer in terms of the original variable, which is x. So let's go back and rewrite this first as minus 1 over 75 times 1 over u cubed plus c, which is minus 1 over 75, 1 divided by sine cubed of theta plus c. Now we can also write this in terms of cosecant, but it's not going to be necessary because we'll have to convert back to x. Recall that our substitution was x equal to 5 tangent theta. So tangent of theta is equal to x divided by 5. And if I draw a right triangle with angle theta, and tangent is opposite divided by the adjacent, so the opposite will be x, the adjacent is 5, and then the hypotenuse will be x squared plus 5 squared under the radical, which is 25. So our solution is minus 1 over 75, 1 divided by sine cubed of theta. Now sine is opposite over hypotenuse, so that would be x divided by the square root of x squared plus 25 cubed plus c. And let's simplify that for the final answer. I'm going to write my integral here once again. The integral, we were looking at x squared plus 25 under the radical divided by x to the 4th can now be expressed as follows. This is equal to, so we flip what's in the denominator. We write a minus. We have x squared plus 25. We had the square root cubed, so that's to the 3/2 power. In the denominator we have the 75 and then x cubed plus c. That's the final answer. For more videos,